So hi everyone, welcome to my vlog. For today's video, we're going to talk about the fault, the types of fault, and its importance in engineering construction. So fault is a normal word to us because we have already encountered this in our previous years. So today, we will tackle it again. So let's go! So let's begin to faults. So what is fault? Fault in geology, a planar or gently curved fracture in the rocks of Earth's crust where compressional or tensional forces cause relative displacement of the rocks on the opposite sides of the fracture. In other words, a fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake, or may occur slowly in the form of creep. Faults may range in length from a few millimeters to 1,000 kilometers. So now that we know the definition of faults, let's proceed to its types. So there are three types of fault. Those are normal fault, reverse fault, and the strike-slip fault. So we will tackle that one by one. So first that we will going to talk about is the normal fault. So what is normal fault? Normal faults create space. Two blocks of crust pull apart, stretching the crust into a valley. The basin and range province in North America and the East African Ridge Zone are two well-known regions where normal faults are spreading apart Earth's crust. So next is the reverse faults, or also called as thrust faults. Slide one block of crust on top of another. These faults are commonly found in the collision zones, where tectonic plates push up mountain ranges such as the Himalayas and the Rocky Mountains. And last but not the least is the strike-slip faults. So what kind of fault is this? So this fault indicates rocks are sliding past each other horizontally, with little to no vertical movement. Both the San Andreas and the Antanolean faults are strike-slip. So here is an image that I can show to you for you to properly understand what are the three types of faults. So in this image, it is clearly shown on how the reverse fault, normal fault, and the strike-slip fault works. So now that you know the definition of faults and its type, let's proceed now to the importance of fault in engineering construction. So let's go. When we say fault, it is considered as a dangerous but useful. So why is it dangerous? Here are some reasons why fault is considered as a dangerous. So first is fault cause considerable damage to rocks and are therefore a real hazard in mining and engineering works. Next is fault breccia and fault gouge or pulverized rocks have low strength and are poor foundation materials. Also, there is additional difficulty and additional expenditure in excavation since fractured rocks are difficult to handle. Earthquake and landslides are likely to be triggered by faults, so that is why they are considered fault as dangerous. So to provide earthquake-proof structures, it is necessary to have a knowledge of the location and an earthquake potential of faults. So these things are particular importance in locating sites for dams, reservoirs, structures, underground power, nuclear power stations, tunnels, public buildings, school and college buildings, etc. The main significance of faults in engineering lies as a plane of weakness affecting physical properties of rocks. Fault may act as a possible source of movement and may pose problem of settlement, sliding, seepage, and seismicity to the civil engineering structures, depending on its nature, deposition, and location. Also, fault zones Also, fault zones control the location, architecture, and evolution of a broad range of geological features, act as conduits for the focused migration of economically important fluids, and as most seismicity is associated with active faults, they also constitute of the most important global geological hazards. So, to sum it up, the importance of fault in engineering construction is it helps us decide on what kind of building are we going to build. For example, if we are close to the fault, we now know that we will going to build in a earthquake-proof building so that it would be unharmful for everyone. So as a future engineer, it is important for us to study geological features so that our building is safe for everyone. So that's it for today's video. Thank you for watching. God bless everyone.